Let me ask you something. When you type a prompt into your favorite AI assistant and it spits out this highly detailed, beautifully structured response in just seconds, does that artificial intelligence actually think? Does it really understand you? Does it actually know the answer? We intuitively assume that it must, right? It sounds like it does, but the truth is actually much more fascinating and honestly a little counterintuitive. Welcome to this explainer. Today, we're going to look under the hood of the systems powering modern AI assistants. If you're using these tools in your daily life or at work, understanding exactly how large language models, or LLMs, actually operate is absolutely crucial. It's the foundation for literally every prompt you'll ever write. And the best part? We are going to explore all of this without getting bogged down in heavy technical jargon. Here's our quick roadmap for today. We'll start with the prediction engine, then move to how language models learn, why AI makes mistakes, a brief AI history, and finally wrap up with choosing the right tool.
All right, let's jump right into Section 1, the prediction engine.
Okay, if you take only one thing away from this entire explainer, I want it to be this core mantra. An LLM does not think, it predicts. It predicts what a useful, coherent response looks like based on its training, your prompt, and the surrounding context. It doesn't reason through things. It doesn't know facts in the way we do. It's simply a prediction engine generating language patterns. When you give it a prompt, it is basically playing the most advanced game of autocomplete ever invented.
So, how does this massive guessing game actually work mechanically? Well, the model predicts just one piece at a time, and that piece is called a token. You can think of a token as roughly equivalent to a word, maybe a piece of a word, or even just a punctuation mark. The AI relies entirely on the statistical relationships it learned during its training to guess what token should logically come next. It looks at your prompt, the history of your conversation, the tokens it just generated, runs the math, and boom, it outputs the next piece of the puzzle, over and over again, token by token.
Moving right along to Section 2, how language models learn.
So if they are just predicting, how in the world did they get so remarkably good at it? It happens in three big phases. First up is pre-training. The model is fed a massive text corpus. We're talking hundreds of billions of tokens from the internet, books, articles, you name it. It learns the deep structures of language and factual associations just by trying to predict the next token and correcting its own errors. Second is fine-tuning. This is where it gets targeted, high-quality examples of the behavior we actually want, shaping its character so it acts like a helpful assistant rather than just a random text generator. And finally, we have RLHF. That stands for Reinforcement Learning from Human Feedback. Basically, human raters literally score the AI's answers, giving rewards for the good ones. This human feedback is the secret sauce that ultimately shapes the AI to be helpful, harmless, and honest.
But here's the catch. Once the AI is trained and you're chatting with it, it has limits. Enter the context window. This is the total amount of text the model can hold in its working memory at any one given time. Have you ever been deep into a really long conversation with an AI and suddenly it just seems to totally forget what you talked about 10 minutes ago? Yeah, this is exactly why. That older text has literally fallen out of its context window. It just can't see it anymore. Understanding this is a real game changer for managing complex chats or really long documents. This whole predicting mechanism also explains the AI's so-called creativity. You've probably noticed that if you ask an AI the exact same prompt twice, you almost always get a slightly different answer. Why is that? Well, it comes down to a parameter called temperature. The model doesn't always pick the single most mathematically likely next token. It samples from a probability distribution. A low temperature means it's playing it really safe and conservative. But crank up the temperature to high, now it's allowed to pick less probable tokens, making the output much more varied, surprising, and creative. Let's dive into Section 3, why AI makes mistakes.
The biggest misconception users have is that AI thinks through problems logically. We assume it reasons. But in reality, AI generates fluent text that mimics reasoning. It has seen so many millions of examples of human reasoning in its training data that it knows exactly what a logical argument is supposed to look and sound like. But remember our core rule: these models are built for patterns, not truth. Sounding incredibly confident is absolutely not the same thing as being factually correct.
Because they are built to complete patterns, we get some very specific and sometimes frustrating failure modes. Let's walk through them. First, hallucination. This is when the AI generates fluent but entirely invented facts. And here's the thing, it's not a bug, it is a structural property of a system that is literally built to complete a pattern. Then there's overconfidence. These systems have zero internal mechanism for uncertainty. They honestly don't know when they don't know. They will confidently state total fiction with the exact same assertive tone they use for actual facts. Next up is the training cutoff. The model's core knowledge stops at a certain date. It doesn't automatically know today's breaking news unless it's specifically hooked up to a search engine. And finally, bias. Because they learn from our human data, they naturally reflect human cultural assumptions and skews.
All right, Section 4, a brief AI history. Looking at the timeline really puts all of this into perspective. Early AI was totally rule-based. Humans had to sit there and handwrite thousands of if-then rules, which made the system super brittle. The next era brought statistical machine learning, where models learn patterns from data. Think of your early email spam filters. But the massive, world-changing breakthrough happened in 2017. Google researchers introduced the transformer architecture. This allowed models to process the relationships between all words in a sequence simultaneously. And then, finally, in 2022, OpenAI wrapped these powerful, complex models into a super simple chat interface with ChatGPT. Suddenly, this technology was instantly accessible to literally everyone. Which brings us to our final part, Section 5, choosing the right tool.
When you look at the landscape today, you've got some major players. There's ChatGPT by OpenAI, which is famous for its broad utility, handling images and voice, and it's great for brainstorming. Then you have Claude by Anthropic. Claude is highly valued for careful, precise writing, and it's amazing at handling massive documents because it has a huge context window. And of course, there's Gemini by Google, which really shines with its deep integration into the Google ecosystem and handling time-sensitive, search-connected queries. Now, the goal here isn't to rank them from best to worst. The crucial takeaway is that they are not perfectly interchangeable. The best tool depends entirely on your specific task. So how do you actually get the most out of whichever tool you decide to use? Well, there's this really common misconception that longer prompts are always better. But in reality, clearer prompts produce better results. Clarity and specificity matter way more than just dumping a massive wall of text into the context window. Think about it, because the AI is predicting based on the context you provide, an overly long rambling prompt can actually confuse the model about what it should prioritize. A focused, well-structured prompt gives that prediction engine the exact constraints it needs to nail the answer.
And that brings us to our final thought for today. The true power of AI isn't in its ability to replace human judgment. Actually, it's the exact opposite. Your human judgment, your critical thinking, and your verification habits are required now more than ever to wield this prediction engine effectively. It's a tool, and you are the one steering the ship. So I'll leave you with this question to chew on. Now that you know AI predicts rather than thinks, how are you going to change the way you prompt tomorrow? Thanks so much for joining me on this explainer, and keep learning.